This puzzle is called, Moulin Noir? Moulin Noir, maybe? By noswald. I got it from the CTC community Discord, the Sudoku testing submissions channel. Uh, yeah, let's look at the rules. Digits connected by a black dot have a 2-to-1 ratio, so that means if we discovered this was a 4, this would have to be a 2 or, a 2 or an 8. Um, Digits separated by an x sum to 10. So, yep, here's an x. If this is a 3, this would have to be a 7. This is not a 7. This is an 8. This has to be a 2, and so on. And digits separated by a v must sum to 5. So these digits add to 5. This could be a 2 and a 3, or a 1 and a 4. Yeah. And not all black dots, x's, or v's are shown. So that's good to know. And yeah, I don't know how hard this is. Let's see. Let me look at this thing. So it was posted about 7 hours ago, and there are 8 solves. So maybe it's not. It's not probably terribly difficult. Yeah, but I'm not sure how it'll go. So you can judge the difficulty a little bit by the length of the video, I suppose. I'm gonna put a link to the puzzle down in the description if you want to solve it yourself. And let's get going. So yeah, I guess I can start with the V's. That's usually a good place to start. This is 1, 2, 3, 4. And the thing I notice now is that whichever pair this is either a 1, 4 or a 2, 3. We don't know which, but it's one of the two pairs. This pair could not be the same. If this was a 1, 4, this couldn't also be 1, 4 because this can't be a 1 or a 4. Similarly, if this was 2, 3, this couldn't be 2, 3. So this is one pair, and this is the opposite pair. And we're gonna continue around the grid like this. So this is the opposite of the opposite. So this is back to the original, and this is also kind of back to the second opposite or the first opposite, whichever way you wanna whichever way you wanna say that. Um, okay, so this X is gonna need a small digit. It's gonna need a 1, 2, 3, or 4 because it's either gonna be like 1, 9, 2, 8, 3, 7, 4, 6, and if we tried to put a small digit here, the puzzle will break because this digit or this cell actually sees all of both blue digits and both green digits, which comprise all 4 small digits. So this actually must be the 1, 2, 3, or 4, and it's going to be in the green, one of these green digits. We don't know which, but it's going to be one of the green ones, and then this is just going to be a big digit. Whoops, or it could be a 6. I just am not good at typing sometimes. This green is going to be different than this green, so maybe we can color that differently. I don't know how helpful that will be. Yeah, I don't know how helpful that will be. But we have the same situation down here. So this cell can't be a 1, 2, 3, or 4 because it sees the 2 blues and the 2 greens both. So this is 1, 2, 3, or 4, and it's blue. Up here, we're gonna do the same thing. This cell can't be blue and it can't be green. So this is the big digit. This is the small digit. It can't be a blue, so it must be green. And then finally, yeah, here. Okay, this can't be blue or green. So this is 1, 2, 3, and it must be blue. And this must be the big digit. Okay. Now this must also have a small digit. Um, this must also have a small digit because if we tried to do a large digit, let's say we put a 6 on this line. If we then wanted to double that 6 and not use a small digit, we would need to have a 12 here, which doesn't work. Even if we put a 5, this would have to be a 10, so that wouldn't work at all. So this has a small digit on it, and it must be a blue small digit. So this must be blue. Now this can't be a small digit. We've now used all 4 small digits in the box. So this must be a large digit. So this, theoretically, this could be a lot of options. 4, 6, or 8. But it can't be a 1, 2, or 4. So it must be a 6 or an 8. Right, I'm trying to think of the implications of that. So this can't be a 1 or a 2, because 1 always goes with 2. 2 can go with 1 or 4, but we've just said this can't be a low digit, so this must be a 3 or 4. This can't be a 3 or a 4 then, which means this must be an 8 or a 9. Is one of these an 8? If this is a 2, this is an 8, so that has an 8. If this is a 1, this is a 4, which makes this an 8. Yeah, so this always has an 8 in here. I don't know if that's useful, but it's always nice to notice things like that. Oh, yeah, okay. Yeah, I also noticed that this row has a 5 and a 7 in it. I don't know if that's helpful or not, but I think it will be, so I'm just gonna mark that down. Let's look down here. Or let's look here. So I think we're gonna have a similar situation as over here. So this black dot is gonna need a small digit, and it must be a green small digit because we've already used both blues in the box. So this must be the green small digit. A 1 goes with a 2, but we can't use two small digits. We must use one small, one big, so it can't be a 1. Can't be a 2 because 2 goes with 1 or 4, and again, it can't be a 1 or a 4 because it needs a big digit. So it's 3 or 4 again. So this is 6 or 8. Now this needs a, this takes the green, larger of the two green digits. So this must be a 1 or a 2. This must be an 8 or a 9. We have 8's looking down. But now where can 5 and 7 go in this box? We have this 5, 7 pointing set over here. So this can't be a 5 or a 7. So 5 and 7 are forced right here. And this is going to be a 6 or a 9 because we need to finish off this triple. We actually have 6's looking back this way. Did I mess that up? Because, I don't know. I don't think I messed that up. But I feel like the symmetricalness might cause problems, so maybe I did. Let's just keep going. So this 6 is looking back over here, so we can't have a 6 in here, so this must be a 6, which forces this to be a 3 and a 2, and this will be an 8. And then this can be a 2 or a 3. So now we know that blue is 2, 3, which makes this a 1, 4, which makes this an 8, a 6, and a 9. And we have 5, 7, 9 left in this box. So far, so good. I don't know. Oh yeah, but I guess these corners aren't exactly the same. On the ones with greens in the corners, the X's are at the top and the greens are away from the side, whereas the ones with blue in the corner have the dot on the side and the X's, away from the wall. So I guess that's how we fix, or we avoid this symmetry. So I was thinking we would force 6 in every single one of these middle cells here, and then of course that would be a big problem. But it's symmetrical, but slightly different. Okay, so this is a 1-4 pair, as this is a not a 1-4 pair. This can't be 1 or 4. This can't be 2 or 3. Okay, so this goes with 7 or 8, but I think we're gonna end up with the same situation that we've been doing with, like, up here. It's gonna probably be a copy of this box, actually. Actually, we just have a 7 looking down, so we don't have to do advanced logic. We just know that this is an 8, 2, so this can't have a 1, 2, 4, or 8 on it, so it must be 3, 6. We have a 3 looking over. This is 3, 6, and we can color that. So what's left is 5, 7, 9. And we have a 5, 7 looking down, so this is 9. This is not 9. Okay. We have a X here, which means this must be a 6 or a 9. And the thing I immediately see is this 5, 7 is looking over. 5, 7 can't be in any of these cells, so this is a 5, 7. And that looks up and makes this a 5, 7. Or sorry, makes it not a 5, 7. It makes it a 9. Then here, we need a green digit. We need a low digit, so this must be a 1 or a 4. We can't put a 1 here because I would put a 2, and we've already used a 2 in the box. So this must be 4, 8. So this is 1, 9. What do we have left is 6. Yeah, and it is symmetrical, but it's slightly different. So the opposite corners are the same, but the adjacent corners are just a little bit off, which is good, because otherwise, the puzzle would be broken. um, so we have greens. Oh, I guess we can just type in what digits are left. So this is 1, 3, and 4, which would make this 9, 7, or 6, just to go with the X, and it can't be a 9, so this can't be a 9. This can't be a 1. We can do the same for this X here. This must be a 9, a 6, 7, or 9, but again, it can't be a 9, so that leaves this as a 1. So this must be a 2, 8, because we've already used 3 7 and 4 6. So the only thing remaining is a 2 8, which is gonna do that. Figure out that 5 7 pair, and what's left is 5. Oh, we have a 3 up here, which makes this a 2, makes this a 3, 2, 8. We also had the 8 there that could resolve that. This is a 5 9. Sometimes I just, actually that same thing is happening all around the grid. This is a, whoops, this is not a 1, this is a 4, this is not a 3. Yeah, and this 1 sets this, yeah. Sometimes I'm slow on the pickup of the basic Sudoku. But hopefully doing a bunch of Sudokus like I've been doing this past week will improve that. This must be 1, 2, or 3. So this must be theoretically 7, 8, or 9, but we have an 8 making it that way. I don't see a way to advance here. One of these is a 4. Yeah, I don't think that's helpful. Maybe this dot, because dots are pretty restricted, but let's look at this first. This is 1, 3, 4. So this is 9, 7, whoops, 9, 7, 6. And it can't be a 9, so this can't be a 1. And these looking over don't matter. So this must be a 2, 8 again, though, because we need a low digit, and it can't be 1, 3, or 4, so this is 2, 8. This 8 figures that out. But looking over that doesn't affect anything, although we have a 2 and the 8 along the middle here. I don't know how helpful that will be, but I think it's probably going to be good to note. For this column, it must be 5, 6, 7 remaining. And for this column, it's 5, 7, 9 remaining. One of these is a 6, one of these is a 9. Okay, I think well, actually, let's fill in this. Must be 1, 2, 3. Yeah, so then what's left? What options are left? We need a low digit, but we can't use 1, 2, or 3. We need a 4. There's a 4 here ruling out here, so this must be a 4. Theoretically, this could go to 2 or 8, but there's a 2 in the box and literally right next to it, so this must be an 8. So this can't be an 8. This can't be a 4, so this is a 4, so we have a 4 up the middle. Do I want to fill that in yet? Probably not. This X theoretically could be 1, 2, or 3, but 2 would put an 8 here, and it can't be an 8. So this is 7 or 9. So we actually have a decent bit looking into this middle box here. So what can this X be? It can't be a 1, 9. It can't be a 2, 8. So it's either a 3, 4. Yeah, it either has a 3, 4. So it's 3, 4, 6, 7. Which does a number of things. But first of all, this can't be a 4, so this can't be a 6. Oh, this can't be a 3 or a 7. That's the easier way. This is a pair of pairs, so this can't be a 3 or a 7. This is just 4, 6. So this is 3, 7. This can't be a 7. Neither of these can be 7s. This must be a 6. This is 5, 7. Whoops. These can't be 3s. This is a 5 or a 9. What's left up here is 6, 5, 7. And it's, oh, and there's a 6 looking up here, so this is just a 6. This is 5, 7, 9. Okay. This is a 5, 7, or 9. I guess 9s are restricted in these two areas. One of these must be a 9. Um, Are there any X's I haven't looked at? Not that I see. Oh, there's a 6 right here. That's what the problem was. Or that's what a problem was, at least. So this 4, yeah, this 4 looks over here. So now we have everything in this row paired up or just typed in. So this is 2, 8, 1 left in the row. This can't be an 8. So one of these is an 8. I don't know if that's helpful. Oh, this number can't be a 1 because we have a 1, 3 pair. What's left in this column? We have a 7, 9 pair, we have a 6, we have a 1, 3 pair, We have a 4, so we have 2, 8, and 5 left. And this can't be a 2 or an 8 because we have already used them here, or we have 2 in the row already. So this is a 5 because we don't have a 5 in the column yet. Yeah, so this must be a 9. This must be a 5, 9, 5, 9. This is 3, 7. Oh, there's a 2 right here. So this is an 8. This is a 2, 1, 8. This can't be a 1. This can't be a 1. What is this? 5, 7, 6. And there's a 6 looking down. Of course, I noticed that right after I type in all the options. There we have a 2, 3 pair here, so this can't be a 3. This is a 7, 3. This can't be a 7. Do I have a 9? Yeah, I do have a 9. It's like I'm pretty sure I have a 9 in here somewhere. I just can't find it. This is gonna finish off the puzzle, it looks like. Oh, this is a 2, this is a 1, this is a 3, this is a 2. This 5 is gonna make these 7s, and this a 5. There we go. That was pretty good. I really liked the corners, figuring out the logic and then having them kind of bounce back and forth. Um, but also be like almost symmetrical. I really liked the opening there. That was really cool. It ended up being maybe like probably 1.5 difficulty. I don't think it probably quite hit 2 difficulty. I don't know, the whole difficulty thing is so subjective. It's hard to say. But I would, oh, sorry for the chair. I would probably say that it's 1.5 out of 5 difficulty because it wasn't like free. It definitely wasn't freebies. Where that's kind of what I put 1 out of 5 as. It definitely wasn't freebies. I definitely had to like do logic and think about things quite a bit, but it wasn't super hard. It wasn't hard either. I don't know. Yeah, I think 1.5 out of 5, but very fun and a very beautiful like that break-in, I guess. Like bouncing back and forth between the corners and having all the corners be almost symmetrical. Like so symmetrical that I thought I broke the puzzle. But then I realized then I realized how I didn't. Anyway, so thank you to Noswald for the puzzle. That was a lot of fun, and thank you all for watching.